Okay, in this video I will teach you one numerical problem regarding the applications of the capacitor in series and parallel combination. So let us first look at the question. So the question says that two capacitors of capacitances 6 microfarad and 12 microfarad are connected in series with a battery. The voltage across the 6 microfarad capacitor is 2 volt. So we have to compute the total battery voltage. So let me answer this question. So here I will say let C1, which is the capacitance of the first capacitor, that is 6 microfarad. So as we know, this microfarad is not the SI unit of capacitance. So therefore, in physics, while doing the numerical problems, we have to look at the units. If the units are not in SI, then first we have to convert them into SI unit. So the SI unit of capacitance is actually farad. So this is microfarad. So how do we write it, or how do we convert into farad? So I convert this into farad by multiplying with 10 to the power minus 6. So it becomes farad. Similarly, the second capacitance is 12 microfarad. So when you convert it, you'll get 12 into 10 to the power minus 6 farad. Alright. Also, because it is given here that the 6 microfarad is having a potential difference of 2 volts. So for that I will write V2. Let's say, V1 is equals to 2 volt. Now I have to compute V2. How much is V2? Alright. So therefore, because these two capacitors C1 and C2 are connected in series. So when you connect the two capacitors in series, right, what happens to the charge? The charge that is passing through C1 and C2 is the same. This is the charge Q which is given by the source. So the same charge Q will be flowing through C1 and C2. So therefore, right, if this is C1, then what is the potential difference across here? V1. Potential difference across here is V2. So if the charge is same, then I will write, because we know from the relation, okay, Q is equals to CV. Okay, so for the first capacitor, the capacitance is C1, the potential is V1. For the second capacitor, the charge is Q, the capacitance is C2, the potential difference is V2. But the charge Q here is same for each capacitor, so therefore I will write C1 V1 equal C2 V2, which means C1 is equals to 6 into 10 to the power minus 6, V1 is equals to 2, C2 is equals to 12 into 10 to the power minus 6, V2 is, I don't know, I have to find out. So this 10 to the power minus 6 from the left, from the right can be cancelled. Multiplying 2 with 6, you'll get 12. Right hand sides will become 12 times V2. So therefore, just V2 here will be equals to 12 upon 12, which means 1 volt. So this is the potential across, the potential difference across the second capacitor is 1 volt. Okay. So, but the question asks you to compute the total battery of the voltage. So what is the total battery? What is the total voltage of the battery? The total voltage of the battery is V. And this V, right, as we have seen during the derivation, it is V1 plus V2. So now your V1 is known, which is 2, V2 is 1. So therefore, the potential difference, or we can say the voltage of the battery, it is 3 volt. So this is the answer. So I hope you are clear with this problem. Thank you very much.